Today we're going to dive into some really fascinating research that asks a wild question. What happens when we give a factory a brain? When the machines that build our world can actually start to think for themselves?
I mean, really think about it. What if a factory could feel when its machines were about to break down? What if it could analyze its own problems and then figure out how to fix itself? It sounds like pure science fiction, but it's actually the very real future of manufacturing. Okay, let's get into this.
So to really get why a factory would even need a brain, we first have to talk about a massive problem they all face, what I'm calling the million-dollar breakdown.
Look, modern manufacturing, it runs on these incredible machines. CNC turning centers, robotic arms, you name it. They are absolute marvels of engineering, put together from literally thousands of individual parts and subassemblies. But here's the thing, that complexity, it's also their greatest weakness. When just one tiny part fails, the entire production line can just grind to a dead stop.
And that stop is expensive. We're talking huge financial losses from downtime, delays that completely wreck delivery schedules, and maybe worst of all, a serious loss of customer confidence. For any manufacturer, an unexpected failure is an absolute nightmare. And, the traditional ways of making sure machines are reliable, they just aren't cutting it anymore.
So why is this so hard to get right? Well, it's kind of the perfect storm. You've got these incredibly intricate machines working in really complex factories. They're being used under all sorts of different conditions by all sorts of different operators. And then, when something does go wrong, trying to track down the real root cause, it's like trying to find a needle in a haystack of messy, incomplete data.
Okay, so how do you solve a problem that complex? Turns out you don't just build a better machine, you build a smarter factory. You give it what's called a digital twin. Basically, a virtual nervous system that connects every single part of the operation.
The key technology behind all this is called a cyber-physical system. Yeah, it's a bit of a mouthful, I know, but the concept is actually pretty simple. It's basically a bridge that connects the physical factory floor, the actual machines and the people, with the cyber world of data, powerful analytics, and artificial intelligence. These two worlds are just constantly talking to each other.
So this framework from the research shows you exactly how it works. It all starts with the physical factory. Then you've got a sensing layer that's capturing data in real time right from the shop floor. That data then flows into the cyber world, where these powerful models analyze it, looking for all those hidden patterns. And here's the really cool part. The system then sends intelligent decisions and action plans right back down to the factory floor to improve the process. It's this continuous loop of learning and getting better.
Of course, this whole system is totally useless if you don't have good data. You know the old saying, garbage in, garbage out. Well, it is especially true here. So the very first challenge was figuring out how to actually listen to what the machines are trying to tell us.
To solve this, the researchers came up with this brilliant little smart device. So, instead of relying on, say, handwritten notes or confusing emails when a machine breaks down, an operator or a service engineer can use this device to log exactly what happened, when it happened, and how they fixed it, all with simple buttons and drop-down menus. It completely transforms all that messy, unstructured info into clean, reliable data.
And that data ends up looking something like this. A 1 just means a failure happened on a specific day for a specific part. A 0 means it didn't. This is the language the computers can actually understand. And when you have this kind of structured data from hundreds of machines over a long period of time, well, that's when you can finally start to see the bigger picture.
Okay, now for the fun part. Let's look at a real-world case study. The researchers took this system and applied it to a manufacturer that had 362 of their CNC turning centers operating out in the field. They wanted to find the hidden culprits causing all their machine failures.
So this is what the raw data on all those failures looked like. Each horizontal line you see is a single machine, and each little vertical tick is a failure event that happened over 1 year. I mean, to you and me, it's just chaos. It looks completely random, right? There's no obvious pattern. It's impossible to know where you would even begin to look for a problem.
But the system's brain could see what we can't. It used a really powerful statistical model to cut through all that noise. So think of it this way. Instead of just focusing on one machine's random breakdown, it looks at the average failure rate across the entire fleet of machines. This lets it cancel out all the random noise and see the true underlying trend of when and how these machines are failing as a group.
And what it found was incredible. Turns out the failures weren't random at all. A few specific parts were the main culprits: the headstock, the coolant system, and the hydraulic system. When you put them together, they were responsible for a huge chunk of the total failures. The system had found the needles in the haystack.
So just how bad was this problem? Well, the analysis revealed that this specific machine model had a reliability of just 13%. That means there was only a 13% chance it could operate for a full year with 0 failures. That is a shockingly low number for a pricey piece of industrial equipment.
So, the system pinpointed the exact problem. But here's where it goes from being just a smart diagnostic tool to a truly revolutionary one. It doesn't just hand you a report and walk away. It gives you a plan.
Let's focus on the worst offender for a second. The headstock, also known as Subassembly S112. The manufacturer's own design goal for this part was 98% reliability over 1 year, but the real-world data showed its actual reliability was only 68%. That is a massive 30-point gap between what they wanted and what they were getting.
And this right here, this is the system's superpower. It doesn't just tell you, hey, your reliability is 68%. No, it automatically generates an entire action plan. It identifies the headstock as the problem, it flags that low reliability number, and it recommends forming a specific failure analysis team. It even checks the company databases to find the right people for that team and points out critical design documents that are missing.
And the impact of this is just enormous. As the researchers put it, this system allowed the manufacturer to execute a fix in a fraction of the time it would normally take. What usually takes months of meetings, of manual data digging, of arguing over who's responsible, was just automated. The factory's new brain didn't just diagnose the illness, it prescribed the cure. Which brings us to a final, pretty big question. We're moving away from factories that simply make things to factories that can learn, adapt, and improve themselves. So, when factories can diagnose and fix their own problems, freeing up engineers to actually innovate, what incredible new things will they be able to build next?